Hey guys, welcome back to my channel. Today we're going to do Pearson Edexcel International Advanced Level Maths. This is going to be pure maths P2 for October 2024. If you're someone who hasn't checked out the video for paper 1, you can access it at the link above. In this playlist, you will come across past papers that I've done for International Advanced Level, and the upcoming days I'll be updating the playlist with the 2025 papers as well. So let's start with this one and see how difficult or easy Pure Math P2 was for October 2024. So the first question says a continuous curve has equation y equals to f of x. We have a table of values of x and y for y equals to f of x as shown below. Using the trapezium rule with all the values of y in the given table, we have to find an estimate for the integral of f of x from the limit of 0.5 to 5.5, giving an answer to one decimal place. So for this, we will directly use the trapezium rule. H over 2 times y naught plus yn plus 2 times y1 plus y2, and we have y1, y2, y3. So our yn is basically going to be y4. H is going to be the difference between two consecutive x values. So 1.75 minus 0.5 divided by 2 times y naught is 3.479 plus y4 5.182 plus 2 times 6.101 plus 7.448 plus 6.823. Plug this in the calculator and what you should get is 30.9. So that is your integral correct to one decimal place. Then it says using your answer to part A and making your method clear, estimate the integral of f of x plus 4x from the limit of 0.5 to 5.5. So now the equation is integral of 0.5 to 5.5 f of x plus 4x dx. So let's split this into two parts. One part is the integral of f of x from the limit of 0.5 to 5.5 from the limit of 0.5 to 5.5, and the other one is the integral of 4x. So we already have the value for the integral of f of x for the given limit, which is 30.9. We integrate 4x, which is going to be 4x squared over 2. We add 1 to the power and divide the term by the new power. So 0.5 to 5.5, that's 30.9 plus 2 times 5.5 square. Remember, we always put the bigger value first, then the smaller value. Minus 2 times 0.5 whole square. That gives us a value of 30.9 plus 60, which is 90.9. That is your answer. So very simple. For this, you need to know the trapezium rule. H over 2 times y naught plus yn plus 2 times all of the middle values for y. Then the second question is about sequences. It says a sequence of numbers u1, u2, u3 is defined by u1 equals to 7, un plus 1 equals to negative 1 to the power of n times un plus k, where k is a constant. We have to show that u5 equals to 7. So first, let's begin with finding u2. So negative 1 times 7 plus k, that's negative 7 plus k. Then we find u3, which is going to be negative 1 to the power of 2 times u2 plus k. That's 1 times negative 7 plus k plus k, negative 7 plus k plus k. So that's negative 7 plus 2k. u4 is going to be negative 1 to the power of 3 times u3 plus k. So that's negative 1 times negative 7 plus 2k plus k. That's positive 7. That's positive 7 minus 2k plus k, which is 7 minus k. So finally, u5 is going to be negative 1 to the power of 4 times u4 plus k, which is going to be 1 times 7 minus k plus k, and that is 7. This is exactly what the question wanted us to prove, and we got that answer. It says given that the sum of UR from R equals to 1 to R equals to 4 equals to 30. We have to find the value of K. So U1 plus U2 plus U3 plus U4 equals to 30. That's what the summation says. So we know U1 is 7, U2 is negative 7 plus K, U3 is negative 7 plus 2k plus the fourth term, which is 7 minus k. So this equals to 30. Collect the like terms. 7 minus 7 cancels out. Again, 7 minus 7 cancels out. So you have k plus 2k minus k. So that's 2k equals to 30. And k is going to be 30 divided by 2, which is 15. That says find the value of, then it says hence find the value of sum of UR from R equals to 1 to R equals to 150. So all of the terms starting from U1 to U150 are being added now. So for that, you need to realize the sequence we're following over here is 7, then negative 7 plus k, negative 7 plus 2k, then 7 minus k, and then 7 is being repeated again. Since we found the value of k, let's plug that in and see what the numerical values are for each term. So we have 7, then we have 8, then we have 23, then we have negative 8, and then 7 gets repeated again. So if you notice, the same cycle is being repeated. We have 7, then we have 8, then we have 23, then we have negative 8, then again 7, then 8, 23, negative 8, and so on. So since we have 150 terms, we know that we have 4 terms repeated each time. It's after every 4 term like the terms are repeated. So if we do 150 divided by 4, that gives us 37.5, which means 37 times 4 is 148. So 148 terms are going to be in the same order. So after 148 terms, 2 terms are going to be 7, and then we're going to have 8 again. So 148 terms, and then this is the last 2 terms. Okay, so the 148 terms are going to end with 7, 8, 23, negative 8, again 7, 8, 23, negative 8, and so on. And then after that, we have a 7 and an 8. So if you notice, we have 38 sevens, we have 38 eights, then we have 37 23s, and 37 negative 8s. This is what's that going to give us the sum of these terms starting from r equals to 1 to 150. So when we add this up, what we get is 1125. That is your answer. So once again, you have to realize that there's a pattern happening in the terms, and then you see till which term the pattern is being repeated. So till the 148 terms, we have the same pattern being repeated, but then we have two extra terms. So 149 term will be 7 and 150th term will be 8. So we have 38 sevens in this sum. We have 38 eights. We have 37 23s and 37 negative 8s. So we add them up and that gives us a value of 1125. That is how you solve this question. Then question 3 says we have a function 2x cubed minus x squared plus x plus ax plus b, where a and b are integers. Given that when f of x is divided by x plus 3, the remainder is 55, show that 3a minus b equals to negative 118. So that means when we substitute x equals to negative 3 in the function, we're getting an answer of 55. So which means 55 is equal to 2 times negative 3 cube minus negative 3 squared plus a times negative 3 plus b. So when we solve this, what we get is 2 times negative 27 minus 9 minus 3a plus b. 55 equals to negative 54 minus 9 minus 3a plus b, which is going to be 55 plus 63 equals to negative 3a plus b, which is 118. So if you look at the format given the question, 3a is positive, b is negative, and 118 is also negative. So that's your answer as asked in the question. Then it says, given also that 2x minus 5 is a factor of f of x, we have to find the values of a and b. So keeping that in mind, f of 5 over 2 is equal to 0. So let's put that in the function. 0 equals to 2 times 5 over 2 cube minus 5 over 2 squared plus a times 5 over 2 plus b. That's going to be 125 over 4 minus 25 over 4 plus 5a over 2 plus b. 125 minus 25 is 100. 100 divided by 4 is 25. Then 25 goes to the other side. Then we take 25 to the other side. Multiply the entire equation by 2 to get rid of the fraction. That's negative 50 equals to 5a plus 2b. So this is one equation. This is the second equation. We're going to solve these two equations simultaneously to find the value of a and b. So let's write them down. I'm going to times the second equation by 2 because I'm going to use the elimination method. And as you know, in elimination method, we have to eliminate a variable. So I want to eliminate variable b first. So that's going to give us negative 236 equals to 6a minus 2b. This is your third equation. Now we're going to simultaneously solve the second equation and the third equation. So since 2b have opposite signs in both the equations, so we're going to add the equations to eliminate it. Negative 236 minus 50 equals to 6a plus 5a. That's going to be negative 286 equals to 11a. Negative 286 divided by 11, and that's going to be negative 26. That's your value of a. Now you find the corresponding value of b, which is going to be 3 times negative 26 minus b equals to negative 118. You can substitute the value of a in either of the equations, equation 1, equation 2, or equation 3. Either will get the same answer. That's going to be negative 78 minus b equals to negative 118. Negative 78 plus 118 equals to b, and that equals to 40. That's your answer. Then part C said, hence find the quotient when f of x is divided by x minus 7. So first, let's write the function. 2x cubed minus x squared minus 26x plus 40. We're dividing this by x minus 7. So we're going to do long division for this. So x times 2x squared gives us 2x cubed. Change the signs. 2x cubed minus 2x cubed is 0. 2x squared times 7 is 14x squared. Originally the sign is negative, so we change it to positive. So that's going to be 13x squared. Everything else comes down as it is. Then we multiply plus 13x with x. That's going to be 13x squared. 13 times 7 is going to be 91, so 91x. Negative sign originally. It's positive originally, we change it to negative. This is negative originally, we change it to positive. That's 0. And 91 minus 26, 65. So 65x plus 40 comes as it is. Then we times it by positive 65. So 65x. Positive originally, we change it to negative. And 65 times 7 is 455. It's negative originally, we change it to positive. So that's going to be 495. So that is your remainder. So the question was asking us to find the quotient. Quotient is going to be 2x squared plus 13x plus 65. That is your quotient. 495 is your remainder. That's your answer. Then it says, in this question, you must show all stages of your working. Solutions relying entirely on calculated technology are not acceptable. The curve C has equation y equals to 4x to the power of 1 over 2 plus 9x to the power of negative 1 over 2 plus 3, where x is greater than 0. We have to find dy by dx, giving each term in simplest form. So we differentiate this equation. And as you know, in differentiation, we bring the power down, multiply it by the term, and then subtract 1 from the original power. So 1 over 2 times 4 times x to the power of 1 over 2 minus 1. Then again, plus 9 times negative 1 over 2 times x to the power of negative 1 over 2 minus 1. And the derivative of constant is 0. That's going to be 2 times x to the power of negative 1 over 2. Be minus 9 over 2 times x to the power of negative 3 over 2. That's your derivative. Then it's saying, hence find the x-coordinate of the stationary point of C. As you know, to find the x-coordinate of the stationary point, we always put the first derivative equal to 0. So 0 equals to dy by dx. So 0 equals to 2x to the power of negative 1 over 2 minus 9 over 2 times x to the power of negative 3 over 2. I'm going to multiply the entire equation by 2x to the power of 3 over 2. Why? This will help us in getting rid of the fraction in the coefficient and the power. Because negative 1 over 2 plus 3 over 2 is going to be 1. And negative 3 over 2 plus 3 over 2 is going to be 0. So that makes the power simpler. So 0 equals to 4x minus 9. So that means 9 equals to 4x and 9 over 4 is the value of x. That's the x-coordinate. Then it says find the double derivative giving each term in simplest form. So for this, we're going to differentiate dy by dx. So the second derivative is going to be 2 times negative 1 over 2 times x to the power of negative 1 over 2 minus 1 minus 9 over 2 times negative 3 over 2 times x to the power of negative 3 over 2 minus 1. Negative x to the power of negative 3 over 2, 27 over 4, x to the power of negative 5 over 2. That is the second derivative. Then hence determine the nature of the stationary point of C, giving a reason for your answer. To determine this nature of the stationary point, we're going to substitute that value in the second derivative. So that gives us a value of 16 over 27. Since it's greater than 0, that means it's a minimum point. If it was less than 0, it would be a maximum point. That's how you determine the nature of the stationary point or any point, as a matter of fact. Then state the range of values of x for which y is decreasing. So for that, we already know that 9 over 4 is a stationary point, okay? So if we go to the equation, it has also mentioned that x is supposed to be greater than 0. So keeping that in mind, your range of values for x where the function is increasing is going to be, it's less than 9 over 4, but greater than 0. So as you know, 9 over 4 is a minimum point which we determined in the previous part. So minimum curve looks like this. So this is where 9 over 4 is, okay? So we know in this direction, the function is decreasing. It's less than 0. Over here, it's increasing. And since x has to be greater than 0, which means between 0 to 9 over 4, it's decreasing, and 9 over 4 onwards, it's increasing. So that's why this is your given range. Then it says find in terms of A, the first three terms in ascending powers of x of the binomial expansion of 2 plus ax to the power of 6, where a is a non-zero constant, giving each term in its simplest form. So we're going to use binomial expansion for this. So that's going to be 2 to the power of 6 plus 6c1 times 2 to the power of 5 times ax to the power of 1 plus 6c2 times 2 to the power of 4 times ax to the power of 2. We just need the first three terms, so we stop over here. We don't expand it completely. So that's going to be 64 plus 192ax plus 240 a square x square. These are your first three terms. Then it says that f of x equals to 3 plus 1 over x whole square times 2 plus ax to the power of 6. Given that the constant term in the expansion of f of x is 576, we have to find the value of a. So we're multiplying both the brackets, and I'm just going to stick to the first three terms. Why? Because if I expand this firstly, that's going to give me 9 plus 6 over x plus 1 over x squared. This is the expansion of 3 plus 1 over x whole square. Now I'm multiplying this with the expansion of 2 plus ax to the power of 6. So if I just write the first three terms over here, we can automatically see that these three terms are enough. We don't need to further expand this because our focus is just on the constant term because they gave us the constant term. So 9 times 64 is constant. 6 over x times 192ax gives us the constant. And 1 over x squared times 240a squared x squared also gives us a constant. So 9 times 64 plus 6 over x times 192ax plus 1 over x squared times 240 a square x square. This equals to 576. So let's expand this. That's going to be 576 plus 1152a plus 240 a square equals to 576. 1152a plus 240 a square equals to 0. A common, so 1152 plus 240a equals to 0. So 1152 equals to negative 240a. 1152 divided by negative 240. And that gives us a value of negative 2405. So that's what a is going to be. The reason why we're not taking a equals to 0 because a equals to 0 cancels out x. So it's not applicable. So this is your correct term for a, negative 24 over 5. Then we have a question on logs. It says in this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So using the laws of logarithms, solve log of 12 minus 2x to the base of 4 equals to 2 plus 2 times log of x plus 1 to the base of 4. So first, I'm going to write a log with 2, which is going to be log of 4 to the base of 4. Why? Because every whole number is being multiplied by 1. And I'm going to replace that 1 with log 4 to the base of 4 because it's basically equal to 1. Then I'm going to bring this 2 over here as a power, which is one of the rules of the logarithms that you can bring a power down by making it the coefficient, and then you can reverse the process as well by taking the coefficient and making it the power of the bracket. Next, I'm going to repeat the same step for the new log. 2 becomes the power of 4. And as you can see now, there is no coefficient and all of the logs have the same base, which means we can start to combine these logs now. Because if the bases are not same, we cannot combine them. When two logs with the same bases are being added, we can rewrite it as a single log where they're being multiplied. So 4 squared times x plus 1 square. That's going to be 16 times x plus 1 square. Which is going to be 16x plus 32x, 16x squared, sorry, plus 16. Another thing, when their logs on both sides of the equal to sign existing singularly and they have the same base, we can cancel those logs out. So we cancel them out and it becomes 12 minus 2x equals to 16x squared plus 32x plus 16. As you can see, the logs are gone and now it's just a normal equation and it's a quadratic equation. Once you collect the like terms and simplify it, we'll be able to solve this equation algebraically, and that will help us in finding the values of x. So bring everything on the right-hand side. (16x squared) plus 34x plus 4. We can divide all of the terms by 2 to simplify it. 8x squared plus 17x plus 2. You can use middle term breakage or the quadratic formula to factorize this. Either way, it's going to be correct. I'm going to use middle term breakage. So 8 times 2 is 16, and factors of 16 that we can use to replace 17 are 16 and 1. So 8x squared plus 16x plus x plus 2. Factor by grouping, so the first two terms make one group and the last two terms make another group. In the first group, we have 8x common. So x plus 2 goes in the bracket. In the last two terms, we have 1 common. So plus 1 bracket x plus 2. So we have x plus 2 bracket 8x plus 1. One value of x is -2 and the other is -1 over 8. Now we have to pick that value which doesn't make the log negative. So if I take -2, 12 plus 4 is 16, but -2 plus 1 is going to be -1. So we can't use -2 because log of a negative number isn't possible, which means this is your final answer. X equals to -1 over 8. Moving on to the next question. Then it says, Jem pays money into saving scheme A over a period of 300 months. Jem pays £20 into scheme A in month 1, £20.50 in month 2, £21 in month 3, and so on. So that the amounts Jem pays each month form an arithmetic sequence. We have to show that Jem pays £69.50 into scheme A in month 100. So let's create our nth term equation first. So A is given as 20. D is going to be 20.50 minus 20, which is 0.5. So UN is going to be A plus N minus 1 times D. So that's 20 plus N minus 1 times 0.5, which simplifies to 20 plus 0.5 N minus 0.5, which is 19.5 plus 0.5 n. You have to find the 100th term. That equals to 69.5. That's your answer. Then you have to find the total amount that GEM pays into Scheme A over the period of 300 months. So sum of the first 300 terms. So S300 is going to be n over 2 times 2a plus n minus 1 times d. That's going to be 300 over 2 times 2 times 20 plus 300 minus 1 times 0.5. Plug it in the calculator and what you should get is 28425 pounds. That is your sum of the first 300 terms. Then it's saying Kim pays money into a different savings scheme B over the same period of 300 months. In a model, the amounts Kim pays into scheme B increases by the same percentage each month so that the amount Kim pays each month forms a geometric sequence. So for Jem, it was an arithmetic sequence, and for Kim, it's a geometric sequence. So given that Kim pays 20 pounds into the scheme as well in the first month, and 250 pounds into scheme B in month 300, we have to use the model to calculate to the nearest 10 pounds the difference between the total amount paid into scheme A and the total amount paid into scheme B over the period of 300 months. So for this, we already have the sum for the arithmetic sequence. We have to find the sum for the geometric sequence. So for that, we need to find the ratio. We know that in the 300th month, when n is 300, U300 is 250 and A is 20. So UN equals to A times R to the power of n minus 1. 250 equals to 20 times R to the power of 300 minus 1. 250 divided by 20 equals to R to the power of 299, which is equal to 12.5 equals to R to the power of 299. Now you find the 299th term on both sides, and that gives us a value of 1.00848 for the ratio. So for the sum of the 300 terms, A times 1 minus R to the power of n over 1 minus R. So that's going to be 20 times 1 minus 1.00848 to the power of 300 over 1 minus 1.00848. That gives us a value of 273.62.948. So we have to find the difference between the two. That's going to be 28425 minus 273.62.948. So that's going to give us a value of 1060 pounds. So I've rounded it up because the question was asking us to round it up. So this is your final answer. Then question 8 says that in this question, you must show all series of working solutions relying entirely on calculator technology are not acceptable. So we have this diagram, this figure 1. I chose a sketch of part of the curve C1 with equation y equals to x squared plus 3, where x is greater than 0. Then it says that a part of the curve C2 with equation y equals to 13 minus 9 over x squared, where x is greater than 0. The curves C1 and C2 intersect at the points P and Q, which is shown in figure 1. We have to use algebra to find the x-coordinate of P and the x-coordinate of Q first. So as you can see, since they're both intersecting at P and Q, so we put both the equations equal to each other, solve it for x, and find the x-coordinates for both P and Q. So let's start with that first. So we have x squared plus 3 equal to 13 minus 9 over x squared. Multiply the entire equation by x squared to get rid of the fraction. X to the power of 4 plus 3x squared equals to 13x squared minus 9. Bring everything to the left-hand side. X to the power 4 plus 3x squared minus 13x squared plus 9 equals to 0. X to the power 4 minus 10x squared plus 9 equals to 0. I'm going to assume that x squared equals to a, which means it's going to be a squared minus 10a plus 9 equals to 0. Now we're going to solve this quadratic equation for a first. A squared minus 9a minus a plus 9 equals to 0. A bracket a minus 9 minus 1 bracket a minus 9 equals to 0. A minus 9 bracket a minus 1 equals to 0, where a equals to 9 and a equals to 1. We've already said that a equals to x squared, which means x squared equals to 9, x squared equals to 1, x equals to root of 9, which is plus minus 3, x equals to root of 1, which is plus minus 1. We know that P and Q are present on the positive side where x and y are both positive, which means P is going to be x equals to 1 at P and x equals to 3 at Q. That's your answer. Then it says that the finite region R shown shaded in figure 1 is bounded by C1 and C2. Use algebraic integration to find the exact area of R. If I draw a line over here, this is given as 1, this is given as 3. So R is going to be area of C2 minus the area of C1. C2 is going to be all of this, and C1 is going to be this part. So if we minus C2 and C1, that gives us R. So this is the equation that we're going to use to find the area of region R. So R equals to C2 minus C1. So area of C2 is going to be the integral of C2, which is 13 minus 9 over x squared from the limit of 1 to 3 dx. Integral of 13 is going to be 3x. Integral of negative 9 over x squared is going to be plus 9 over x. Why? Because it's going to be 9 times x to the power of negative 2, add 1 to the power, divided by the new power. So that gives us 9 over x. Limit is from 1 to 3. So 13 times 3 plus 9 over 3 minus 13 times 1 plus 9 over 1. That gives us 39 plus 3 minus 13 plus 9. That equals to 20. Now area of C1, that equals to the integral of x squared plus 3 dx from 1 to 3. That's going to be x cubed over 3 plus 3x. So 3 cubed over 3 plus 3 times 3 minus 1 cubed over 3 plus 3 times 1. 27 divided by 3 is 9 plus 9 minus 1 over 3 minus 3. That gives us 44 over 3. So R is going to be 20 minus 44 over 3, which is going to be 60 minus 44 over 3, and that is 16 over 3. That's your answer. Question 9 says, in this question, you must show detailed reasoning. Solutions relying entirely on calculated technology are not acceptable. You have to show that the equation 2 tan theta equals to 3 cos theta can be written as 3 sine square theta plus 2 sine theta minus 3 equals to 0. So let's rewrite tan theta as sine theta over cos theta first. Cross multiply. That's 3 cos square theta. Replace cos square theta with 1 minus sine square theta. And this way the entire equation will be in terms of sine as asked in the question. Bring everything on one side. So 3 sine square theta plus 2 sine theta minus 3 equals to 0. Exactly the same as the equation in the question. Then it says, hence solve for x is between negative pi to positive pi. The equation 2 tan of 2x plus pi by 3 equals to 3 cos of 2x plus pi by 3, giving your answers to 3 significant figures. So what we can do is we can see that it's the exact same equation as in the first part, but they've just replaced theta with 2x plus pi by 3. So if we solve for equation in part A, whatever values we get, we can replace the theta with 2x plus pi by 3 and then use that to figure out the value of x. So what we'll do is we'll solve this equation first. We can't use middle term breakage for this. We're going to use the quadratic formula. Sine theta equals to negative 2 plus minus 2 square minus 4 times 3 times negative 3 over 2 times 3. That's going to be negative 2 plus minus square root of 40 over 6, which is going to be negative 2 plus minus 2 root 10 over 6. Simplify, so negative 1 plus minus root of 10 over 3. So sine theta equals to negative 1 plus root 10 over 3, and sine theta also equals to negative 1 minus root 10 over 3. So when you find sine inverse of this, That gives us a value of 0.8048. And when you find sine inverse of this one, it's not applicable. So now we know that x is supposed to be between negative pi to pi. So firstly, sine is positive over here, 0.8048, and then it's over here, 0.8048. Okay. So theta is going to be 0.8048, and it's also going to be pi minus 0.8048. So the other value is going to be 2.3367. So which means 2x plus pi by 3 is equal to these two values. Now we have to figure out the value of x. So to find the value of x, it's going to be 0.8048 minus pi by 3 divided by 2, and same for the other value, 2.3367 minus pi by 3 and divided by 2. So that gives us negative 0.121, and then we get 0.645. Now if we make a graph over here, negative 0.121 is going to be over here and over here. Our limit is from negative pi to positive pi. So for another value for x, we're going to do negative 0.121 plus pi. And for 0.645, which is going to be in the positive side, we're going to do 0.645 minus pi. This will allow us to have two more values, so in total 4 values for x. So plus pi with negative 0.121, that gives us 3.02, and 0.645 minus pi, that's going to be negative 2.50. So x is going to be negative 0.121, 0.645, 3.02, and then negative 2.50. These are your values of x. Then question 10 says the circle C has equation x squared plus y squared plus 4x minus 30y plus 209 equals to 0. We have to find the coordinates of the center of C and the exact value of the radius of C. So for that, we have to convert the equation of the circle into completing square form. Let's rewrite the equation. X squared plus 4x plus y squared minus 30y equals to negative 209. X squared plus 4x plus 2 squared minus 2 squared, and then for y it's going to be y squared minus 30y plus 15 squared minus 15 squared equals to negative 209. If you're someone who still doesn't know how to use completing square form, you can check out the link above. In this video, I've discussed several questions for completing square form in detail using past paper questions. So this becomes x plus 2 whole square minus 4 outside plus bracket y minus 15 whole square minus 225 outside and then negative 209 over here. So x plus 2 whole square plus y minus 15 whole square equals to negative 209 plus 225 plus 4. That equals to 20. So if you remember, for a circle, the equation is x minus h whole square plus y minus k whole square equals to r square. So based on that, the coordinates for the center are going to be negative 2 and 15. And for the radius, it's going to be square root of 20. Because this value is r square, so r is going to be root. So root of 20. Then says line L has equation y equals to mx plus 1 where m is a constant. Given that L is the tangent to C at the point P, show that 2m squared minus 7m minus 22 equals to 0. So to solve part B, what we're going to do is we're going to first do the intersection of the line and the curve, make an equation, and we're going to use the discriminant as well for that because the line and the curve are tangent to each other. So let's begin with substituting y equals to mx plus 1 in the curve first. So we have x plus 2 whole square plus y minus 15 whole square equals to 20. So replace y with mx plus 1. So it's going to be minus 14 over here. Expand the brackets. X squared plus 4x plus 4 plus m squared x squared minus 28mx plus 196 equals to 20. Collect everything on one side, x squared plus m squared x squared plus 4x minus 28mx. 4 plus 196 is 200 plus 200 minus 20 equals to 0. So x squared plus, so x squared bracket 1 plus m squared, then plus x bracket 4 minus 28m plus 180. I've just simplified the equation. Now, if you remember, when a curve and a line are tangent to each other, the discriminant we follow is b squared minus 4ac equals to 0. So we're going to use this and rewrite the equation in terms of m now and make it exactly the same as given the question. That is going to be 4 minus 28m whole square minus 4 times 1 plus m squared times 180 equals to 0. Expand the bracket. 16 minus 224m plus 784 m squared minus 720 minus 720 m squared equals to 0. Collect the like terms. 64 m squared minus 224 m minus 704 equals to 0. Simplify it, and that gives us m squared. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything by 32. 32 m squared minus 704 m squared equals to 0. Simplify it by dividing everything and that is going to give us 2m squared minus 7m minus 22 equals to 0. That's your answer. Then for part C, it says hence find the possible pairs of coordinates of P. So for that, we're going to solve this quadratic equation first. So 2m squared minus 7m minus 22 equals to 0. 2 times 22 is 44. Factors of 44 that we can use to replace 7 are going to be 11 and 4. So 2m squared minus 11m plus 4m minus 22 equals to 0. M is common, so 2m minus 11 plus 2 bracket 2m minus 11. 2m minus 11 times m plus 2. So one value of m is 11 over 2 and the other is negative 2. So these two different values of m are going to help us in finding the possible values of p. So for that, we begin with finding the value of p at m equals to 11 over 2 first. So replace that into the initial equation. So we had x plus 2 whole square plus 11 over 2 times x minus 14 whole square equals to 20. We solve this. X squared plus 4x plus 4 plus 121 over 4x squared minus 154x plus 14 squared, which is 196, equals to 20. Collect everything on one side. And then we factorize this equation. So first collect the like terms. So x squared plus 121x squared is going to be 125x squared over 4. And then we're going to have negative 150x and plus 180 equals to 0. Get rid of the fraction by multiplying everything by 4. That's going to be 125x squared minus 600x plus 720 equals to 0. Now we factorize this. And what we get is 5 times 5x minus 12 whole square equals to 0, which means x is going to be equal to 12 over 5. Now to find the corresponding y value, we can put it into the linear equation. So y equals to mx plus 1. So y equals to 11 over 2 times 12 over 5 plus 1, which gives us a value of 132 over 10 plus 1, and that's going to be 142 over 10, which we can simplify to 71 over 5. That is your y value. Then for the other x value, use m equals to negative 2. So repeat the same steps with this value. So x squared plus 4x plus 4, I'm just directly using the expanded version, plus negative 2x minus 14 whole square equals to 20. X squared plus 4x plus 4 plus 4x squared plus 56x plus 196 equals to 20. Collect the like terms. 5x squared plus 60x plus 180 equals to 0. Factorize this equation, and that gives us a value of 5 times x plus 6 whole square equals to 0, which means x equals to negative 6. So once again, to find the y value, negative 2 times negative 6 plus 1 and that's going to be 12 plus 1, and that's 13. So these are your possible values of p. X equals to 12 over 5 and y equals to negative. So p can be x equals to 12 over 5, where y is 71 over 5, or p can be x equals to negative 6 and y is 13. These are the two possible values for p. Then for the next question, it says prove by counterexample that the statement if n equals to a prime number, then 3 to the power of n plus 2 is also a prime number is false. So we're going to assume that n equals to, let's say, 5. It can be any prime number. You can say 2 or 7 as well. If I pick 5, it's going to be 3 to the power 5 plus 2. So 3 to the power 5 plus 2 equals to 245. And we know any number that ends with the 5 is in the 5 times table, which means not a prime number. So it's false. Then for the second part, it's saying use proof by exhaustion to prove that if m is an integer that is not divisible by 3, then m squared minus 1 is divisible by 3. So if it's not divisible by 3, let's assume that m is 3k plus 1. If it was just 3k, it would be divisible by 3. But since I'm adding 1 to it now, it's not divisible by 3. You can also add 2 to it. You can also minus 1 from it or minus 2 from it. Either way, it's setting the same example. So what we're going to do is, if m equals to 3k plus 1, that means m squared minus 1 is going to be 3k plus 1 whole square minus 1. Expand the bracket, 9k squared plus 6k plus 1 minus 1, which is going to be 9k squared plus 6k. Now we very well know that we can take 3 common over here. So 3 times 3k squared plus 2k. It is divisible by 3, which the question was asking us to prove. Now we can use another example where we're saying it's even now, 3k plus 2. This was for odd. This is for even. Because it can be an odd integer and an even integer. So if it's an even integer, m squared minus 1 would be 3k plus 2 whole square minus 1, which is 9k squared plus 6k plus 4 minus 1, which is going to be 9k squared plus 6k plus 3. Again, we can take 3 common. So 3k squared plus 2k plus 1. In both cases, it is divisible. In both cases, it is divisible by 3, given that m is an integer which is not divisible by 3. And with that, we're done with Pure Math Paper 2 for October 2024. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends, and don't forget to check out the other videos in this playlist.